Hi children, now we can discuss on sulfur and its allotropic forms. What is meant by allotropy? As you know, allotropy means an element can exist more than one form. When you take carbon's allotropic forms, graphite, diamond, fullerene, likewise there is a different forms carbon can exist. Likewise, sulfur's allotropic forms here we are discussing. The specialty of allotrop means, which all forms the element can exist, all the elemental forms, it is having different physical properties and same chemical properties. In the case of sulfur, there is a lot of allotropic forms it is possible, but in your textbook and in this 12th standard we have to study only two allotropic forms of sulfur, that it is alpha sulfur and beta sulfur. Alpha means rhombic sulfur and beta means monoclinic sulfur. So only about these two allotropic forms we have to be discussed today. Both ones physical properties it is different, but the chemical properties it is same. Then the stable form of sulfur at room temperature, it is yellow rhombic sulfur. The color is yellow for this rhombic sulfur, that's why we are mentioning as yellow rhombic sulfur. And the monoclinic sulfur, which is stable only above 369 Kelvin, that is 96 degrees centigrade. Okay, so at room temperature rhombic sulfur it is existing when the temperature is above 369 Kelvin, which is transformed to monoclinic sulfur. We can discuss about this in detail today. So first one, rhombic sulfur. Alpha sulfur, it is the another name of this rhombic sulfur. Its color is yellow. Its melting point is 385.8 Kelvin and its specific gravity it is 2.06. Now we can discuss on the preparation of rhombic sulfur. For that you have to take the sulfur first, and in that you have to add carbon disulfide. Mix well. So after that mixing, try to filtration. So when we are trying to filtration, you will get the filtrate. The filtrate you have to be collecting in another beaker and cover it with the filter paper. Okay, then after some time you can see that the carbon sulfide in this solution in the filtrate, so that will be slowly evaporate out and leaving behind the rhombic sulfur. Rhombic sulfur you can see in the form of octahedral crystals of rhombic sulfur. It is possible to see in this beaker after removing CS2. CS2 is evaporating alone. Okay, that way you can prepare rhombic sulfur. Important properties of this rhombic sulfur, it is forming octahedral crystals and it is soluble in CS2 and insoluble in water, and also some amount of that one it is soluble. That means some extent it is soluble in benzene, alcohol and ether. Next one we can discuss on about monoclinic sulfur. Melting point it is 393 Kelvin. Specific gravity it is 1.98. And it is insoluble in CS2. Rhombic sulfur it is soluble in CS2, but this monoclinic it is insoluble. So from that itself you can understand that physical properties it is different. Then it is stable only above 96 degree, that means 369 Kelvin. Then when we are keeping this monoclinic sulfur in a room temperature, that means in our atmosphere, it is slowly convert back to this rhombic sulfur. Otherwise you can say alpha sulfur, when we are trying to be heat, it will be changed to monoclinic sulfur, and also alpha sulfur it is stable below 369 Kelvin and it transforms to beta sulfur above this. Okay, at 369 Kelvin both forms it is stable, above below, that is the two category. Above monoclinic sulfur it is stable and below rhombic sulfur it is stable. So at 369 Kelvin both forms it is stable. That temperature we are calling the name is transition temperature. Now we can discuss on the preparation of this monoclinic sulfur. For the preparation of monoclinic sulfur, you have to take the rhombic sulfur in a dish and try to melt it. Then after melting, try to cool it. Then at the time of cooling, you continue the cooling till the crust formation it is happening over the surface. Then when the crust it is formed, you have to make two holes in the crust. Then through these holes, the molten sulfur melting the happen. No? That molten sulfur you have to be poured out. Then the crust it is to be removed. The lower side of the crust, that means this lower side of the crust, you can see needle shaped, colorless crystals of monoclinic sulfur. Okay, that is the way we can prepare monoclinic sulfur. Then we can discuss about the structure of sulfur now. Both the rhombic and monoclinic sulfur, it is having S8 molecule. Both the monoclinic and rhombic sulfur, they forms ring, S8 ring, and it is having puckered and crown shaped structures, but they differ only in the symmetry of their crystals. Okay, so this is the puckered shape, just like a W crown. When you turn it, you can see that just like a crown, the structure W. Likewise, it is existing. Okay, this is the easiest way of drawing this. This is S8 ring, crown shape S8 ring of rhombic sulfur. Here I drawn monoclinics. There is a change in the crystal, symmetry of the crystal. Okay, this one more form I drawn here. It is said to be that E sulfur. I told that already. Not only alpha beta, there is a lot of other allotropic forms of sulfur. It is possible. Its name is Engel's sulfur. It is unstable and contains SS6 rings. It is also called cyclo-S6. In this E sulfur, the ring adopts the chair form. That is the structure here I shown. Then next, one more point we have to be discussed about S2 form. So S2 form at elevated temperature, that means approximately 1000 Kelvin. So S2 is the dominant species. We discussed about that at 369 Kelvin. Below and above cases we discussed it. But almost 1000 Kelvin when it is there, that time S2 form it is more stable. And S2 is the dominant species, and it is said to have paramagnetic character like O2. Why it is said to be paramagnetic? You know that S is the structure at 16, and you have to be see that 2 unpaired electrons here when we are trying to write the electronic configuration. Because of the 2 unpaired electron in the antibonding pi orbitals, like oxygen, when we are trying to draw the molecular orbital diagram of sulfur S2, O2's diagram you knows that. So likewise, when we are trying to draw the molecular orbital diagram of S2, you can see that it is the antibonding molecular orbital, that is pi star orbital. It is having the unpaired electrons, 2 unpaired electrons. That's why it is having the paramagnetic structure. And in the vapor state, partially the sulfur it is existing as an S2 molecule. Okay, this is the reason for the S2 exhibits paramagnetism.